Alright, hey everybody, I'm Jen Foxbot, and in this video I'm going to teach you about serial communication. I'm going to gloss over it a little bit, but I kind of want to talk about how it works. And I'm going to show you how you can start programming with sensors or other devices that communicate using serial communication. It's not super difficult, but it is kind of important to understand, the fundamentals of how it works so that you can go and read the data sheet for whatever sensor you're using and actually make sense of it and then implement it in programming. So I'll, like I said, cover serial communication, talk about how you implement this protocol and how you actually read the data sheet and what to look for. Okay, so first of all, serial communication is sending information one bit at a time, and by bit, I mean binary. And if you've following some of my other stuff, binary is actually how computers communicate. So when we're talking about electricity, we're talking about sending information in terms of ones and zeros, and that's done in a few different ways. Either you send a voltage, you can have a magnetic sensor or something like that. I don't want to get too much into that, but basically just trust me that we send information to computers and talk to computers in binary at the fundamental level. And so this is a diagram thanks to Wikipedia, which is super awesome. I kind of pulled this quick diagram from there. So you can visualize it like your sender. So the computer that you're programming is your output device. Or I guess it kind of depends. If your sensor is sending information to your computer, then your sensor is the output device. But basically it's one device talking to another device at a time. And so the way that it goes is that the sender sends 8 bits of information to the receiver, and they're labeled D0 through D7, and this is an example of a binary bit, or well, bits, series of bits, binary byte that is sent to the receiver. The first bit that's sent is called the least significant bit, and then the last one that is sent is the most significant bit. Although the way that it's drawn, it appears to be that D7 comes in first. So that's really a quick overview of serial communication. So how do you actually implement it in your code? Okay, so step 1 is to find a library. So depending on what programming language you are using, for the project I'm currently working on, I'm working in Python. So you would want to find a serial communication library for that programming language. And fortunately, there are lots of lovely folks that write libraries, and so there's libraries for pretty much every language you'd be working in. In Python, I'm using the library called SMBus. And so once you've found your library, you go ahead and download it, and then you read about the library functions. And so in this case, one of the functions is write byte data, and that is defined as first comes the device address, and then the command, and then the value that you want to write to that command. There's a bunch of other different functions, but those will all be listed in the library documentation, and so you just pull out the ones that you need. Okay, so now what do you actually do with this function now that you have it? Well, now we have to go and look at the data sheet for the sensor. So, I'm going to swoop up to my computer, wait for it to register. So, in the data sheet, you would find basically where it tells you how to talk to the sensor. So these are essentially the different commands that you can give to your sensor. So if I scroll up really quick, here's a table that shows you all of the different commands that you can give to the sensor. And the register address is really what we want to pay attention to right now. So then when we scroll down, we can see more details about that register. And what we see here is basically, that is table 16. That is what's telling us the bytes that are being sent. So each of these boxes correspond to a different binary bit. And then when we scroll down, we can see more information about what is contained in those bits, or basically what it means and how we can control them, and by controlling them, what are we telling the device to do, whether it's the sensor or the computer. In this case, we're writing a byte, so probably we're using the computer to talk to the sensor and set up some like basic initialization parameters. So in this case, the first 3 bytes are the power mode selection. The second 2, DR1, DR0, are the data rate selection, or basically how fast our sensor is going to be sending us data. And then the last 3 are enabling the X, Y, and Z axis. You might have guessed this is an accelerometer. So I wrote it down in more detail here. So basically, these first 3 bits, like I had mentioned, are the power mode selection. So assuming these are all zeros, that's what your binary bit would look like. So just a series of 8 zeros. That's not super interesting. So what you would do is look at the data sheet again to figure out what the different modes are. So I see 001 is normal mode, so that's what I want. My first 3 bits are going to be 001 to tell the sensor that I want to operate in normal mode. The data rate that I would want is 50 hertz. Again, you get this from the data sheet. And then the last 3, I would like to enable them, please, because I want to use all 3 axes in my accelerometer. So then my last 3 bits for register address 20 are just 111. So that is the binary command that I want to send to my device. So then what you do is you go and look it up what that would be in hexadecimal. And so that tells me that when I look it up, it gives me 27 in hex. If you get really good at this, you could probably do it by memory. And then I'm going to ignore all this. This is my other stuff. So this is a little bit of a different one, but basically that's what you do. You have your function write byte data. You put your device address. Not going to cover that, but that's basically where the sensor is on your computer. And then the command, so that would be the register. So the one we were just looking at would be 20. This is a different command, so this one allows me to do different selections. So that's the command address. And then that's the actual value. So here's another example where I figured out the binary code that I want to send, and then I convert that into hex, and then that's how I implement it in my library function. So yeah, after you have figured that out, the last step is to implement that, and then you put this in your code. And so you run these different functions to configure the sensor, and also to be able to read in information. So for example, the read byte data. That's a tongue twister. Write byte and read byte. The read byte data would function in a very similar way, and you would again go back to your data sheet, and you would just scroll down until you find the one to read. So I have to go kind of far. Oh, so there we go. So in read byte, you would look for this one. So read byte data would be very similar. You would have a device address, which would be the same. The command for this one, it would be 028, and then the value. Yep, so pretty straightforward, hopefully. That was a lot of information. So let me know if you have any questions about that. And remember that libraries are your friend, and also data sheets are super helpful. But hopefully now it makes it a little bit easier to read them. Yay! All right, thanks for watching, and see you next time.